The next type of hypothesis test we're going to discuss is a two-variable chi-square test. Two-variable chi-square tests are used when we have observations or participants that are cross-classified in terms of two qualitative nominal variables, also known as categorical variables, to test any existing relationship or association between these two variables. For example, if we were looking at the relationship between gender and ethnicity, or the relationship between obesity status and whether or not someone has anxiety. Two-variable chi-square tests are also known as tests for or of independence. As we're going through the procedures for a two-variable chi-square test, let's do so using example data. Let's say we want to examine if there's any association between being a smoker and what state you live in. We take a sample of 200 people from two states, California and Indiana, and record their state of residence and assess whether they are a current smoker or not. Results of our survey are presented in the two-way table or contingency table below, also known as a crosstab or cross-tabulation. The null hypothesis in a two-variable chi-square test makes a statement about the lack of relationship between the two variables of interest. It claims that there is no relationship or association between the variables. In other words, using our example, the null is claiming the proportion of smokers should be the same in each state. The null hypothesis is stated as the two variables are independent. So in our case, our null is that state of residence and smoking status are independent. Our alternative hypothesis claims that the null hypothesis is false. In other words, there is an association between the two variables of interest where they are not independent. Our alternative hypothesis, or H1, is stated as the null, or H0, is false. To test whether or not an association between the variables exists, we are comparing observed frequencies to frequencies expected if the null hypothesis was true, similar to what we did in a one-variable chi-square test. If the observed frequencies are similar to the expected frequencies, the results would be considered a common occurrence and we would fail to reject the null. If the observed frequencies are not similar to the expected frequencies, the results would be considered a rare occurrence and we would reject the null. Our observed frequencies in our two-variable chi-square test are going to be our frequencies or numbers that we observe in the sample. For example, two of our observed frequencies using our example data will be the 25 people who were smokers in California and the 35 people who were smokers in Indiana. To find the expected frequencies for each cell in our table for a two-variable chi-square test, we will go cell by cell and multiply each row total associated with the cell by the column total associated with that cell, dividing that quantity by the total sample size. Looking at the example below, to find the expected frequencies for cell A, I would take the row total associated with cell A, which is A plus B, times the column total associated with cell A, which is A plus C, divided by the grand total, or total sample size, which in this case is A plus B plus C plus D. When conducting a two-variable chi-square test in SPSS, SPSS will calculate the expected frequencies for each of the cells of your contingency table for you. Once we find our expected frequencies, the actual calculation of our two-variable chi-squared statistic is going to be the same as our one-variable chi-squared statistic, which is the sum of the observed frequencies minus the expected frequencies squared divided by the expected frequencies. Our degrees of freedom in our two-variable chi-square test is going to be different than in our one-variable chi-square test. Our degrees of freedom will be the number of categories of our one variable, which another way to look at would be the number of columns in our table, or C, minus 1, times the number of categories of our other variable, which another way to look at would be the number of rows in our table, or R, minus 1. When conducting a two-variable chi-square test in SPSS, SPSS will also calculate the degrees of freedom, test statistic, and p-value associated with your test statistic for you. To make a decision about the null hypothesis, we will compare our p-value to an alpha level that we will choose when making our decision rule. If your p-value is greater than your alpha level, you would fail to reject or retain the null hypothesis. This would indicate your test results are not statistically significant based on your chosen alpha level. If your p-value is equal to or less than your alpha level, you would reject the null hypothesis. This would indicate your test results are statistically significant based on your chosen alpha level.